Swayam Prabha. Digital India. Educated India.
In the past 3 lectures, we have been looking at or reviewing vectors. So, in this problem solving session, I will be solving a few problems using the concepts that you have learned, more of a review of your the material that you have learned in your 11th and 12th grade. So, problem number 1 is how to make vectors that extend from one point to another, and will also give you a feel for 3-dimensional visualization. So, the problem is coordinates of the tail and head of some vectors are given below, which of these vectors are equal. So, coordinates are given. One is from 1 1 0 to 2 1 0. Second one is from 2 1 3 to 5 6 1. Third one is from 2 3 5, these are x, y and z coordinates, 2 3 3 5. Fourth one is from -3 to 0 to -2 to 0, and fifth one is from -3 -2 -1 to 0 3 and -1. Notice that I did not follow the system properly. I should put a comma between these x, y and z coordinates. So, let us look at each of these vectors. Okay. If I look at the first one, which is from 1 1 0 to 2 1 0, let us look at this vector in a pictorial manner. Let me make x, y and z coordinates, and what I am looking at, the first vector is from 1. So, I will go 1 step in the x direction and 1 step in the y direction. This is point 1 1 0, and the vector extends from 1 1 0 to 2 1 0. So, the head would be 2 steps in the x direction, 1 step in the y direction. This is the point 2 1 0. So, vector obviously is now, its tail is at 1 1 0, head is at 2 1 0. So, the vector goes like this. You can easily see that this vector v, if I call it, is nothing but 1 step in the x direction I. Let us do it mathematically. Mathematically, the vector is x 2 minus x 1 I plus y 2 minus y 1 j plus z 2 minus z 1 k, and that immediately gives you that this vector is I. What I want you to notice though is, when you practice these problems, make these diagrams. So, remember vector 1 is I. How about vector 2? Vector 2 is from 2 1 3 to 5 6 1. let us try to make this vector. This is x, y and z. So, let us make the tail point. It is 2 steps in x direction, 1 step in y direction and 3 steps in the z direction. So, 1 step, 2 step, 3 steps. This is the point 2, 1 and 3. How about 5, 6, 1? Let me make that with green. So, 2 steps, 3 steps, 4 steps, 5 steps in the x direction, 6 steps in the y direction. So, 1 step, 2 steps, 3 steps, 4 steps, 5 steps, 6 steps in the y direction and 1 step in the z direction. This is point 5, 6, 1. Right. So, this is point 5, 6, 1. The earlier point is 2, 1, 3. The vector is going to be like this. This is the vector. Keep in mind that two vectors are equal even if they are moved parallel to themselves. So, even if I move the tail to the origin, I will produce an equal vector. How do you represent this vector? Again, I will write x 2 minus x 1 I plus y 2 minus y 1 j plus z 2 minus z 1 k. So, this comes out to be 3 I plus 5 j minus 2 k. You can already see that this vector kind of points in the direction positive x direction, positive y direction, but negative z direction. If I were to make it from the origin, it will be 3 steps in the x direction 1, 2, 3, 5 steps 1, 2, 3, 4, 5 in the y direction and 2 steps in the z direction. This vector, if it moves parallel to itself, the same vector as this. So, this is the second vector. Third vector is going to be, now I am not going to make pictures again and again and just give you the answers 2, 3, 5, 2, 3, 3, 5. Again making the vector is going to be x 2 minus x 1 I plus y 2 minus y 1 j plus z 2 minus z 1 k, which will come out to be I. You can already see that vector in 1, which was I, and 3 are equal. Vector number 4 is from minus 3 to 0 to minus 2 to 0. This is also equal to, if I write this as x 2 minus x 1 I plus y 2 minus y 1 j plus z 2 minus z 1 k, this is also equal to I. So, 1, 3 and 4 are equal vectors. How about vector number 5? Vector number 5 is from minus 3, minus 2, minus 1 to 0, 3 and minus 1, and vector is therefore going to be 3 I plus 5 j and that is it. So, this is not equal to anything. This is problem number 1. Let us solve problem number 2. A rectangular room has length 5 meters and width and height 4 meters. A fly is at the center of its floor and flying towards one of the corners of the room with speed 0.5 meters per second. Express its velocity as V x I plus V y j plus V z k. So, to solve this, let me first make the room. So, let its length in this direction x direction be 5 meters, let its width be 4 meters and height be 4 meters. So, the room looks like this. And let us take this point out here to be the origin. The fly initially as is at the center of the floor, this is the floor. So, let us see what is the coordinate of the fly. So, fly is the coordinates of the fly at, let us say, t equal to 0 when it starts flying are 2.5 I plus 2 j, where I have taken the lengthwise this direction towards the length to be x, this width y and height to be z. Initially, the z coordinate of the fly is 0. Let us take one of the corners, all right. Let us take this corner out here. Let us say this fly is flying to this corner. So, fly goes towards the corner given by, what will be the coordinate? This corner lies in the y z plane. So, its vector is going to be x coordinate is 0, y coordinate is 4 j plus z coordinate is 4 k, and it is flying in a straight line. So, the fly would be going in the direction from center to this corner. So, its velocity obviously is in this direction. Let us find this vector in this direction, find the unit vector in that direction and multiply that by the speed 0.5 meters per second, and that will give me the velocity vector. So, the vector in which direction it is moving v is nothing but again x 2 minus x 1 I plus y 2 minus y 1 j plus z 2 minus z 1 k, which is equal to minus 2.5 I plus 4 minus 2, 2 j plus 4 k. This is the direction in which the fly is flying. The magnitude of this vector is going to be V x square plus V y square plus V z square root, which is equal to square root of 2.5, which is 5 by 2 square plus 2 square is 4 plus 16. Let us see how much is that. So, the magnitude of V, this vector, is nothing but square root of 25 by 4 plus 4 plus 16, which is equal to 1 by 2 is square root of 25 plus 16 plus 64, which is 1 over 2 square root of 105. So, unit vector in the direction of fly's flight is going to be equal to the vector in that direction divided by its magnitude, which is equal to 5 by 2 I plus 2 j plus 4 k divided by 1 over 2 square root of 105, which is nothing but 5 I plus 4 j plus 8 k over square root of 105. So, the velocity vector of fly is going to be the magnitude of the velocity, which is 0.5 meters per second, times this unit vector 5 I plus 4 j plus 8 k divided by square root of 105, right, which is equal to, let me write the final answer in black, 2.5 I plus 2 j plus 4 k divided by square root of 105 meters per second. That is problem number 2. Problem number 3. Using graphical method of adding vectors, show that vector addition is commutative. You are learning a new word out here, probably some of you already know it, a commutative. What commutative means is, if I add vector A to B, then order does not matter, the same as B plus A. Whenever you switch the order and do an operation and the result is the same, is called commutative. So, what we want to show is that A plus B is same as B plus A. So, graphically, how do I add two vectors? I will make vector A, and from the head of A, I will make vector B. You may say, but how come you are making them in the same plane? Well, the thing is that if there are two vectors, they always will make a plane. So, I can always put that plane on the plane of this screen, and the net vector, let me make that in red, is given by this red line A plus B. However, recall that vectors, if they are transported parallel to themselves, they are equal. So, I can take this B and transport it parallelly to this side, so that the tail of this vector B is at the tail of A. Similarly, I can transport this A up and bring it here. So, this, because I have transported the vector parallel to itself, it remains equal to A, and I have transported vector B parallel to itself, it remains vector B. This is a parallelogram. And you can see now, by definition of addition, I have started with the tail of B, went up to its head, and on the head I put A and went up to the head of A. So, this is also B plus A. It is the same diagonal which is A plus B and B plus A, and this immediately shows that A plus B is same as B plus A. That means that the addition is commutative. At the same time, I will extend this problem and show that subtraction of two vectors is not commutative. Again this word commutative. What that means is, if I take A, subtract B from it, it will not be the same as B minus A. If it were commutative, it will be equal. Okay, that is the meaning of word commutative. So, again let us make vector A and this is vector B. Recall what do I do in subtracting a vector? I will first make minus B. Minus B means that it points in the direction opposite to vector B, and every other magnitude and everything is the same. So, A minus B, this is minus B. So, A minus B is going to be from the tail of A to the head of minus B, and this is A minus B. On the other hand, B minus A is not going to be this. For B minus A, what will I do? I will go to the head of B and subtract A from it. That means, I will have to take minus A. So, if I transport A out here, this will be A parallel to itself, and minus A would be in the other direction. This will be minus A, right. This is A, and therefore, B minus A is like this. This is B minus A. If you plot this very make it carefully, you can see immediately that they are parallel. A minus B and B minus A are parallel, but in the opposite directions, and therefore, graphically what you have shown is A minus B is same as minus B minus A. Problem number 4. Again, this problem will give you an idea of 3-dimensional visualization and also how we add vectors algebraically. So, the problem is 3 forces of magnitude F, 2F and 3F act at a point with their line of action along the 3 diagonals of a cube, 3 diagonals of the 3 surfaces of a cube with corner at that point with a corner. I will explain this in a figure again. Find the net force and its magnitude. So, let us see what is the problem. Problem is that if I have a point, make a cube at this point. Let us make a cube with a corner at this point. This is a cube at this point, to show that point. And let us also designate this direction to be x, this direction to be y, and this direction to be z. The problem says that there are 3 forces acting at this, and one force acts along this diagonal, its magnitude is F. The other force acts along the other diagonal, let us say in the x z plane, and its magnitude is 2 f, and the third force acts in this direction in the y z plane, and this magnitude is 3 f. We want to find the net force acting at this point and the total magnitude. Let me call the green force acting in the x y plane as F 1, the blue force F 2, and the purple force F 3. So, naturally, F net is going to be F 1 plus F 2 plus F 3, and we will now do this addition algebraically, right, by taking the components of the forces. So, let us see now F 1, let me make this again, the green force is F 1, the blue force is F 2, and the purple force is F 3. F 1 is in the x y plane, let me write this x, y and z, and this is along the diagonal of a cube. So, this angle is 45 degrees. So, is this angle, and so is this angle. This is in the y z x z plane. Okay. So, F 1 I can write as its component in the x direction, which is going to be f cosine of 45 degrees, and it is in the x direction, plus its component in the y direction f sine of 45 degrees in the j direction, and there is no component in the z direction because it is in the x y plane. So, this is f over root 2 I plus f over root 2 j. Let us see F 2. F 2 is in the x z plane, and again it makes 45 degrees from both from the x axis and the z axis. So, this is going to be, and its magnitude is 2 f. So, it is 2 f cosine of 45 degrees in the x direction plus 2 f sine of 45 degrees in the y direction. So, this becomes 2 f over root 2 I plus 2 f over root 2 j, and F 3 is equal to, is in the y z plane. So, this is 3 f cosine of 45 degrees in the j direction plus 3 f sine of 45 degrees in the k direction. This comes out to be 3 f over root 2 j plus 3 f over root 2 k. So, F net, let me write it on this side, F net, which is F 1 plus F 2 plus F 3, is now very easy to calculate, because I can add the x components, y component and the z components, and this gives me 3 f over root 2 I plus F 2 is in the j component is going to be f by root 2 and 2 f by root 2, and this was not in the j direction, this was in the k direction. So, let me correct this, this is in the k direction. So, F 2 is going to be plus, j is f and 3 f. So, this is f plus 3 f, 4 f by root 2 j plus k is this and this, 5 f over root 2 k. So, that is my net force, and its magnitude is going to be equal to square root of 3 f over root 2 square plus 4 f over root 2 square plus 5 f over root 2 square, which comes out to be 5 newtons. Right. So, that is the problem of adding forces. Next, problem number 5. is calculate the rectangular components of a 100 Newton force shown in the figure. And what is shown in the figure is the x, y and the z axis, and the 100 Newton force is acting in this direction such that it makes an angle of 30 degrees from the z axis, and its projection in the xy plane makes 45 degrees from the x axis, and therefore, same angle from the y axis also. So, you can see if it is a 3-dimensional thing or something like this, it is pointing at 30 degrees from here and 45 degrees if you project it here, all right. So, x is making that angle. Now, we want to calculate the rectangular components. Z component is very easy to calculate. F z is going to be f dot k, which is nothing but f cosine of 30 degrees, which comes out to be 100 times root 3 by 2 newtons, which is 50 root 3 newtons. That is very easy. How about the x and y components? So, again let me make this picture. Here is this force, its z component we found out, and its projection in the x y axis, this is 30 degrees, and therefore, the other angle from the x y plane is going to be 60 degrees. The length of this projection is going to be therefore f, let me call this x y in the x y plane, right. Its magnitude is going to be f sine of 30, right, which is nothing but 50 newtons. So, you can see that this 100 newtons force is actually a sum of z direction component, a component in this direction, a component in this direction, which make a component in this direction, which is 50 newtons. Its projection on x and y plane therefore, is going to be f x is going to be 50 cosine of 45 degrees, which is 50 over root 2 or 25 root 2 newtons, and f y is going to be again same angle 25 root 2 newtons, and therefore, this force can be written as 50 root 3 k plus 25 root 2 I plus 25 root 2 j. It does not matter which order we write it in. I could also have written this as 25 root 2 I plus 25 root 2 j plus 50 root 3 k. That is the force. Finally, the last problem in this, two vectors A and B are such that they make angles alpha 1, alpha 2, alpha 3 and beta 1, beta 2, beta 3 from the x, y and z axis respectively. Find cos theta if theta is the angle between A and B in terms of alpha 1, alpha 2, alpha 3 and beta 1, beta 2 and beta 3. We are going to make use of the fact in this case that A dot product B is given by magnitude of A, magnitude of B product cosine of theta, where theta is the angle between them. Now, what you are given is, suppose I look at vector A, right. This vector A is such that it makes an angle alpha 3 with the z axis, alpha 2 with the y axis and alpha 1 with the x axis. So, you can see that the x component of A is going to be A dot I, which is going to be magnitude of A cosine of alpha 1. Y component of A is going to be A dot j, which is going to be magnitude of A cosine of alpha 2, and z component of A is going to be A dot k, which is going to be magnitude of A cosine of alpha 3. Similarly, for B, I can write B x, which is going to be magnitude of B cos of beta 1, magnitude B y is going to be magnitude of B cos of beta 2, and magnitude B z is going to be magnitude of B cos of beta 3. And therefore, now it is very straightforward that A dot B, which is nothing but A x B x plus A y B y plus A z B z is going to be magnitude of A times magnitude of B cosine alpha 1 cosine beta 1 plus cosine alpha 2 cosine beta 2 plus cosine of alpha 3 cosine of beta 3. On the left hand side, I am going to have magnitude of A times magnitude of B times cosine of theta, and this immediately gives you that cosine of theta is cosine alpha 1 cosine beta 1 plus cosine alpha 2 cosine beta 2 plus cosine alpha 3 cosine of beta 3.